Okay, let's go over a few of these homework problems from 11.1, 11.2 so that you'll have an idea what to do. Many of you have already done these, but we'll go over these answers so that you'll have an explanation. It says determine whether the polynomial function, whether the function is a polynomial. In number 1, it says f of x equals 3x plus x to the negative 9. This is not a polynomial because you cannot have a negative power of x. So this answer is C. Number 2 says, is this a polynomial? If so, what is the degree? And it says it is a polynomial of degree 3. It is a polynomial of degree 3. A polynomial cannot have negative exponents. It can't have fraction exponents. Those are your rules for polynomials. Determine whether f of x represents a polynomial function. If it is, state its degree. X to the 5th plus 3x plus 8. It is a polynomial. The leading coefficient is 1 and the degree is 5. Is this a polynomial? Number 4, it is not a polynomial because you cannot divide by a variable. Determine if the following function is a polynomial. If it is, identify its degree. Again, you can't have a denominator that's got a variable in it. If you were to work that out and simplify it still would have a variable. So this is not a polynomial. Number 6. Number 6 says determine if the following is a polynomial function and identify its degree. Well, number 6 is not a polynomial because your exponent cannot be negative. It also cannot be a fraction. So this one's not a polynomial. The degree of the polynomial function is, and here the degree, when you get through multiplying x cubed times x and times x, you're going to have degree 5. And the leading coefficient, well, when you multiply those, both of those are 1s, you're still going to have negative 2 as your leading coefficient. Number 8, the student incorrectly gave 8 as the leading coefficient of the polynomial. What went wrong? Well, what's the highest power? 6. So what's the leading coefficient? Negative 3. So number 8, the answer is C. To identify the leading coefficient, you need to write the polynomial in descending powers. The leading coefficient here is negative 3. Synthetic division. Let me set up synthetic division and then we'll get started. Okay, to set up synthetic division, I want you to think about setting the denominator equal to 0. Then x would be 3, and so that's what goes there. It's the opposite of what you see here when it just starts out with a 1. But if you set the denominator equal to 0, that's what goes in the box. Then you take your coefficients and you line them up. Okay, drop the 1. 1 times 3 is 3. When you combine, you get negative 2. Multiply it back. Negative 2 times 3 is negative 6. When you combine here, you get 0. This would be your remainder. Okay. Now you went from degree 2 and you divided it by degree 1. So the degree goes down 1 and this answer is 1x minus 2. Or you might simply write x minus 2. Okay, so we get ready for number 10. We drop the 4. 4 times 3, or that's a 3. Four times 3 is 12. 12 combined with negative 1 is 11. 11 times 3 is 33. 33 minus 5 is 28. So on number 10, we are going to have 4x plus 11. Now here's what you do with your remainder. It's positive, and you put it over the divisor. Okay? So that's our answer for number 10. Okay, I want to be sure and do number 11 because negative 2 is going to go in the box, because if you set this equal to 0, you would get negative 2. Across the top, you want to start with your highest power, which is x to the third. The coefficient there is 1. And then you move down to x squared. The coefficient there is negative 1. We don't have a plain x term. We don't have an x to the first power or anything. So you need to put a 0 in for a placeholder, and then your constant is 3. And then we'll drop the 1. 1 times negative 2 is negative 2. We combine and we get negative 3. Negative 3 times negative 2 is 6. We combine and we get 6. 6 times negative 2 is negative 12. We combine and we get negative 9. So we start here. We started out degree 3, dividing by degree 1. So we're going to reduce it by 1 power. 1x squared minus 3x plus 6 plus negative 9 over x plus 2. And that came from right there. Okay? So that's how you do that one. Okay, number 15. This is x to the 5th's coefficient right here. And then 0x to the 4th, 0x to the 3rd, 0x squared, 0x, and then your plus 1. So here we go. 1 times negative 1 is negative 1. We combine and we get negative 1. Negative 1 times negative 1 is 1. We combine and we get 1. 1 times negative 1 is negative 1. We combine and we get negative 1. Negative 1 times negative 1 is 1. We combine and we get 1. 1 times negative 1 is negative 1, and we have a remainder of 0. So this is 1x to the 4th minus 1x cubed plus 1x squared minus 1x plus 1. Number 15 doesn't have a remainder, so that's your answer. Your ones out front are optional except for that one right there. Okay, we're asked to determine whether this is a 0 of the polynomial, so we just plug that in. And when you plug that in, you're going to have 3 open parentheses. You're going to use that value for x, so it's going to be 3 cubed minus 4 times 3 squared plus 3 minus 48. And it turns out that it is 0, so it is a 0. So the answer is yes. You just plug it in and check. Okay, for 3 minus I, we're going to turn this into mode. Let's choose A plus BI. Hit second quit, and we're going to plug this in place of x. So it's going to be open parenthesis 3 minus, the I is blue down here at the decimal right here, so you're going to have to hit second and that button, it'll put you an I in there, and you want that squared, plus 3 times 3 minus I, plus 3. It turns out that it's 20 minus 9i. So this is question number 18. And the answer for 18 is, the given number is not a 0, because when you plug it in, you get 20 minus 9i. Decide whether the following statement is true or false. Yes, if this is a factor, then if you set it equal to 0, that value would indeed make that equal 0. So number 19 is true. Okay, if I plug 1 in, and I plug 1, plug 1 into that formula, I'm going to get 1 plus 4 plus 9, which is going to be 14. So it's not a 0 because f of 1 turned out to be 14. I also want you to see what happens here. If I drop that 1 and I use synthetic division, 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. I'm going to get a remainder of 14. Those are connected, okay? That's going to happen like that every time. So you can either use synthetic division or you can use the factor theorem. Okay, 23 says using the given zeros, write the complete factored form of f of x. Guys, this is pretty simple. If x equals -1, then what was the little math problem when it equaled 0? And that would be x plus 1. If x equals 3, then we must have had x minus 3 equals 0. If x equals 5, we must have had x minus 5 equals 0. So your factors would have been x plus 1 times x minus 3 times x minus 5. Find the zeros of the polynomial. You just set those equals to 0, which is just the opposite of what we just did. But I want to talk about this graph. Use the graph to list the factors. Well, there's one there at -3, and another one at -2, and another one at 3. So those are your zeros. So the factors would be, if x equals -3, then I must have had x plus 3 equals 0. If x equals -2, I must have had x plus 2 equals 0. And if x equals 3, I must have had x minus 3 equals 0. So the factors would have been x plus 3 times x plus 2 times x minus 3.